All right, let's jump right in. And I want you to forget every boring math class you've ever had. Today, we are cracking a secret code, a code that explains why things all around us shrink, why they fade away, and even disappear. And trust me, by the end of this, you're going to have a new superpower, the ability to predict the future. Well, sort of.
You know that feeling, right? You get your paycheck and it feels like your bank account just starts shrinking immediately. Or you buy that brand new, shiny phone and the second you take it out of the box, it's already losing value. Heck, even a viral meme goes from hilarious to ancient history in like a week. It all feels random, but it's not. It's all connected by one powerful idea.
So what if I told you there's a single, simple formula that explains all of this? A kind of mathematical key that not only tells you why it's happening, but lets you predict exactly how much of something will be left days, weeks, or even years from now. If that sounds cool, you are in exactly the right place.
Now, we're not going to call it a formula. That sounds like homework. We're going to call it what it really is, a cheat code. A cheat code for understanding anything that gets smaller over time. And right now, we're going to unlock it together.
Okay, here it is. This is our master key. Now, don't let all the letters scare you off. I promise each part is super simple. We've got our starting amount, P, multiplied by what I like to call our shrink ray, that's the 1 minus r part, and it's all raised to the power of t, which is just time. Let's break down each piece one by one. First up is P. P is just your starting point. Think of it like your health bar in a video game when it's at 100%. Or maybe it's the pile of cash you have before you go shopping. It's simply the original, full amount of whatever it is we're looking at. Easy enough, right?
Okay, next up is my favorite part, the decay factor, or the shrink ray, ZAP. Every time you use it, whatever you started with gets a little bit smaller. And here's the key. Since we're making things shrink, this number will always be less than 1. Makes sense, right?
And finally, there's T. T is just for time, but really it just tells us how many times we get to fire that shrink ray. If we're talking about 1 year, you fire it once. 10 years, you fire it 10 times. It's just the number of times the decay happens.
Okay, quick huddle. I'm about to give you a pro tip that's going to save you a ton of headaches. This is the one thing, the one part of the cheat code that trips almost everybody up. But not you, not today.
Let's talk about the decay rate versus the decay factor. The rate, which is R, is the discount. It's the 10% off sticker. It's what you're losing. But here's the secret. Our cheat code doesn't care about what's gone. It only cares about what's left over. So if you lose 10%, that means you have 90% left. And that 90%, or 0.90, is your decay factor. That's the number you actually use.
All right, enough talk. Let's put this cheat code to work with a real-world problem. So, a business saw its sales drop by 10%. They started out making over $100,000. The question is, can we use our code to figure out what they made this year? Yeah, we absolutely can.
So, we just take our starting amount, P, we multiply it by our decay factor, which is 0.90, right? Because 10% is gone. And since it's only 1 year, our T is just 1. You plug that into your phone's calculator and boom, there's the answer. You just predicted a company's sales. How cool is that?
So we know how to punch in the numbers, but what does this stuff actually look like? You know, seeing it can make it click in a totally new way. Let's visualize what this downward slide is all about.
Check out this graph. Just imagine each one of these dots is the value of your phone at the end of every year. The first dot is what you paid for it, the second is what it's worth a year later, and so on. You don't need to be a math genius to see the pattern here, right? It's going downhill, and it's going downhill fast. And now watch what happens when we connect those dots. It's not a straight line at all. We get this awesome, swooping curve. See how it drops really steeply at the beginning, and then it starts to kind of level out? That shape right there is the classic signature, the fingerprint of exponential decay.
Okay, you've totally unlocked the cheat code. You've officially leveled up. And now we're going to take this idea from figuring out shopping sales to uncovering the age of actual dinosaur bones. We're going to do it using an amazing concept called half-life.
So what in the world is a half-life? Well, it sounds complicated, but it's really not. It's just what it sounds like. It's the amount of time it takes for something to decay to exactly half of what it started with. It's like a super predictable countdown.
And just look at the absolutely wild range of half-lives out there. You've got uranium-238, which takes 4.5 billion years for half of it to disappear. That's literally how scientists figure out how old the Earth is. And then you have something like nobelium-257 over here, with a half-life of just 23 seconds. It's basically gone in the blink of an eye.
All right, I've shown you the cheat code. I've shown you how it works on everything from money to ancient radioactive stuff. So now it's your turn. You have the tools. Let's see you put them to the test.
Okay, here's the scenario. Picture a lake with 950 largemouth bass swimming around. But there's a problem. The population is dropping by a huge 35% every single year. So the question is, after 15 years, how many of those fish are still left? Take a second, think about it.
The answer is one. Just one. One single bass is left swimming in that entire lake. Isn't that wild? You start with almost 1,000 and you end up with one. That right there is the shocking, mind-blowing power of exponential decay. A steady drop can have an unbelievable result over time.
So there you have it. You've got the cheat code for exponential decay, you know the crucial difference between a rate and a factor, and you even know the secret of half-life. See, this isn't just about math problems. It's a tool for understanding how the world around you actually works. You have the code now. So my question for you is, what are you going to predict next?